Right. Welcome back. We are on activity 11-4. We're trying to extend the congruence criteria. Specifically, we're just going to be practicing with all of the congruence criteria, including RHL, right hypotenuse leg. So at this point, we should have gone through the other activities, and we're not actually going to go through a lot of this stuff here in 11-4. We're going to do a couple of the important things to make sure we understand like what RHL is, but we're also going to just get to some practice on this. So some of this will be from the textbook PDFs, and some of this is going to be, if you look under the video links, there's some triangle congruency proofs, extra practice. Some of it will be there. So if you need to access the resources I'm using later on, that's where you'll find them. All right, so our goals basically are to make sure we can also practice angle, side, triangle congruency, and right hypotenuse leg for triangle congruency, these two here. All right, so let's skip down a couple of pieces here, and let's look at this example proof that we have here. It says we have some given information. Triangle MNO and triangle PQR with N is congruent to Q. So angle N is congruent to Q. Angle O is congruent to R. So O is congruent to R. And side MO is congruent to PR. So MO is congruent to PR. So what this one does is we're not proving that the triangles are congruent using angle, side. What they're doing is proving that angle, side works for proving congruency. So we're not going to have to create a proof like this at any point and go through all of these steps that they have listed here. This is just, I think in your book it doesn't have the stuff worked in. We're not going to take time proving that angle, side, angle works. We're just going to actually use it. However, there is a new type based on the examples on what pages are we on now? 162. We do have some triangles with one angle and a couple of sides. You'll notice the angle is not included in between the sides. So we actually have angle, side, side on each of these triangles. And you're like, oh yeah, that's one of the ones that doesn't work. Donkeys and batteries. But some of these do look congruent, and some of them don't look congruent to each other. The ones that do look congruent would be A and C. And what's special about those, making them look congruent as opposed to the other ones that don't look congruent, is you'll notice both of those have a right angle. And that's why we do have congruency criteria called RHL that does work for proving congruency, because if you happen to have your angle is a right angle and then the other two pieces you have a hypotenuse and a leg, that is the same thing as angle, side, side, but specifically your angle is a right angle. You actually have two sides of a right triangle, which means the third side has to be whatever you get using Pythagorean theorem. So if you use Pythagorean theorem on this triangle, even though I don't know these sides right here, I would get a value here. We could call it x. It's going to be the exact same value for this one over here because Pythagorean theorem will only get you one answer if you plug in your c value and one of the leg values for this. It looks like I just made a bunch of circles on there. But basically, if you have angle, side, side, but the angle is a right angle, RHL does work for proving congruency. So angle, side, side does not work. But RHL, right hypotenuse leg, sometimes referred to as just hypotenuse leg, does work for proving congruency. I like to use RHL just because it's the three pieces that we're looking for. All right, so let's go back and look at an example down on page, what page are we on? 163. All right. So it says, is it possible to prove these triangles are congruent using HL? If not, what additional information do you need? So it looks like only one piece on each triangle is given. If I tried to add some information, I don't have any vertical angles, but I do have shared sides. There's no parallel lines, there's no definition. So I do have two pieces. I do have sides, two pairs of sides that are labeled as congruent. Each of them have two sides. If you're trying to use right hypotenuse leg, the hypotenuse is a side, the leg is a side, we'd need a right angle. So to be able to use this one, we'd need a right angle that's opposite of one of these two, so that the hypotenuse would be labeled as a right angle. Excuse me, the hypotenuse would be one of the pieces we're using. So this one looks like it's a right angle. If I was to label that, that would be one piece of additional information that these are perpendicular. That would create my right angles on both triangles, my hypotenuse on both triangles, and then I'd have a leg on both triangles as well. So each piece there would then be labeled right hypotenuse leg. I'd have enough to prove it congruence. So the only other piece you would need is that KM is perpendicular to JL. And that would be enough information because that would create your right angles so that you could have a right angle on each triangle, hypotenuse on each triangle, and a leg on each triangle. All right, for number 8, leg-leg congruence. Is there a leg-leg congruence for right triangles? Quickly want to address that. If you have a couple of triangles that have the two legs are labeled as congruent, yeah, that does work because that's already one we've talked about. That is side angle side congruency. It says answer this in complete sentences, but if you turn what I just said into a sentence, that would work. Leg-leg congruence criterion is just side angle side. All right, so let's do some of these practice questions and then jump to the additional practice that I have posted on the video page for 11.3 and 11.4 from the video page. So on question 9, it says, on a coordinate plane, plot these triangles and then prove them congruent. Okay, so if I was to plot these triangles, I guess I'd need a grid. Let's actually go to a GeoGebra page. If you go to the website and on the home thing, there's an additional, let me see if I can get there. Yeah. So on the home page, there's additional resources. You can go to this GeoGebra app on your computer. I'm pretty sure it works on phones as well. But if you do that, you're actually able to get a little page where you can plot points, you can draw lines. So if you wanted to plot a point, you can just click on point and put points wherever you want them, like -3, 3. I already put some here, set it up for the question that we're using. If you wanted to put more points and then connect the dots, you can plot another point and then scroll down here to a segment if you wanted to create a segment between them. And what's great about this is, I mean, obviously you can create midpoints and angle bisectors, perpendicular. You can do a lot of constructions on here. What's also great is you can find like the distance between these points. So I think like, you know, obviously if I could find the distance, then I could prove these congruent. So where is that at? Distance. Oh, there we go. Distance. If I click on these two, it tells me the distance between them. So that's convenient. In any case, I'm actually going to do this using, let's pretend we're taking a test and I don't have GeoGebra. I could plot these and then use the distance formula. So let's go ahead and look at this. These are the points plotted that are listed on that question. On page 164, tells you the coordinates of A, B, C. I plotted that one, made it a triangle, and D, E, F. All right. So then how could we prove this? Well, if you were to find the distance of AB, or let's start with the shortest side. Let's say BC. I could break this down into a right triangle. Whoops. And or I could use the distance formula. In any case, I would get the change in x and the change in y here as 2 and 1. So if I did the distance formula, That's the same thing as if I did the distance formula like this. The difference between them is how much it changes. So this is like a squared plus b squared equals c squared. They just took the square root. So the distance is the piece right here that we're looking for, side G. Any case, changing x is 2. Changing y is 1. So 2 squared is 4. 1 squared is 1, so 4 plus 5, I get d equals square root of 5. You'll notice, without actually having to solve for this completely again, I have the same two sides of a triangle, 2 and 1, so when I plug in the pieces, that piece is going to be the same. So this distance is square root of 5, and this distance is square root of 5. If I wanted to solve the other pieces, let's go ahead and save a little bit of time solving for some of these other pieces. Let's say the distance of AB is going to equal square root of the two pieces for AB would be 2 and 3. I'm not going to write it on there. So 2 So 4 plus 9 will be 13. So square root of 13 for this one. And this piece over here is going to have the same two side lengths, side of 2. I'm looking at ED right now. So is going to end up equaling, let's see, from E to D, a side length of 2, a side length of 3. So it's literally going to be the same equation. I'll get square root of 13 as well. And then if you wanted to check the last pieces, AC, I could draw, let's use a slightly different color here. 1, 2, 3, 4, and 2. So 16 plus 4 is square root of 20. If you wanted to simplify that, I could rewrite this as 4 and 5, so 2 root 5. This is fine, but just to check the distance. But if you needed to use this as an answer for something, you could simplify it to 2 root 5. If you don't know what I did, the getting ready section of activity 2 talks about simplifying radicals. And this other piece down here has the same two. Change in x and change in y, 4 and 2. So we're going to get the same thing for FD as well. So even without doing the work, just looking at what your change in x and change in y are, you can determine if they're going to end up being the same length. So AC equals square root of 20, and FD will also equal square root of 20. So what I've done in this problem is I've verified that these pieces are congruent, these pieces are congruent, and this last piece down here is congruent. So I could prove these are congruent by using the side-side-side congruency criteria by going through piece by piece and determining AB. What was the first one that I did? AB? No, that wasn't the first one. BC. BC equals FE equals square root of 5. So those sides were congruent. That's the side that we would use, for one of our sides and using side-side-side. The other one, we'd say these two pieces are equal. That's another side. We could do another statement. These two pieces are equal. That's our third side. Once we've done all three of the pieces, we could say that the two triangles are congruent by side-side-side. All right. Let's go back to this page here. I'm not sure what happened with the size of this. Oops. And let's actually just look and see if we can prove, based on the information here that's given, if these triangles are congruent. So we're not going to do proofs. We're just going to see if we have enough information to prove congruency now that we know what RHL is. So looking at these, looks like they both have two pieces of information on the top triangle and the bottom triangle. We need to see if we can find another one. So our list of things that we could look for, remember, are vertical angles, shared sides, parallel lines cut by transversal, and definitions. Oops. So I do see shared sides on there. So now I check, is this one that works? If I'm just looking at sides and angles, I have an angle and two sides. And I see that the angle is not included in between the two sides. If it's included, like on the top triangle, it'd be right here, included in between the two sides. Or on the bottom triangle, it'd be right here. That's not what we have. So we do have an angle, and then a side, and then a side. We have an angle, side, side. So you're like, oh, this is donkey. This one doesn't work for proving congruency. However, because this is a right angle, we don't have angle, side, side. We have a right angle, a hypotenuse on both of these, and a leg on each one of these. So we actually have RHL on this one after we get those shared side in the middle. So we could say RHL. On this next one, if I look, I only have two pieces, so I go through these, see what I got. I do have vertical angles I could label. And that's it. There's nothing else you could label, even though everything else looks congruent. You can't label any other angle or side is congruent just because it looks congruent. So going through, I have two angles and one side on each triangle. So it could either be angle, angle, side, oops, or angle, side, angle. Is the side included in between the two angles? Nope, it's not right here. So it looks like I do have angle, angle, side. Angle with one arc mark, angle with two arc marks, side, one arc, two arc, side. Same thing on both triangles. Got to check to make sure it's the exact same information. So angle, angle, side does work on this one. All right, here on number 12, I only have one piece, but I do see there's a shared side. I don't have anything else on this one, so not enough info because there's no vertical angles. There's no parallel lines cut by a transversal. They look parallel, but nowhere on here does it tell me that they're parallel with, extra set of arrowheads on there. So I can't label this one anything else. There's no definition or anything to label, basically. So not enough info. And number 13, looks like we have segment PR bisects angle SPT. So let's trace out SPT is this piece here, and PQ bisects it, so it cuts that angle in half. So that means these two angles are the ones that are going to be congruent there. So let me make that a little bit easier. This angle here is congruent to that angle there. Do I have any additional information on this one? So conveniently, I do have shared sides again. So it looks like each triangle has two pieces. Do you see any vertical angles? No. Do you see any parallel lines? No. Do you see any definitions? Well, we already put bisects. We already labeled that part. That's all we got. Not enough info. All right. So at this point, hopefully you have a list somewhere of the triangle congruency that does work and the triangle congruency that doesn't work, or the criteria that doesn't work for proving congruency. I'm going to jump to this page here. Nope, not this page. This page here. This is the first of two additional practice pages that I have listed. All right, maybe I'll just put my face over here. All right, for each of these problems, we're going to be doing trying to see if we can prove these triangles are congruent. It's basically just practice for you guys. I'm going to work through a couple on this page and then just give the answers for the rest of them. That way, instead of you thinking you know what you're doing and copying down my answers, you can try them on your own and then come back later and check your answers. So let's start with number 1. And I'm going to make a quick list just in case you don't already have it somewhere of the ones that do work. So these are listed right here, the 1, 2, 3, 4, 5 possible combinations that do work for proving congruency. If you don't have that written down somewhere and you don't have them memorized already, write it down somewhere. And you also need to remember the combinations that do not work for proving congruency as well. So you need to make sure that you remember, there we go, angle, angle, angle does not work because that creates similar triangles, not necessarily congruent. And then angle, side, side. So donkeys and batteries is an easy way of remembering those. And that's kind of what I tell people to focus on, because any other combination, any of these other ones we came up with do work. And this one, if you happen to have a right angle, you might want to check right hypotenuse leg on that one. All right, now that we reviewed those, let's go ahead and get started. First step of any proof is label the given information, any definitions. See if you know why these are congruent before you start trying to fill any blanks down here. So given BC is congruent to DC. So BC, DC, great. Next given AC, EC. So AC, EC. Prove these are congruent. So it looks like each triangle only has 2 pieces. You're going to need a third piece. You go through the list of things. We do have a list of 4 things we can check. Shared sides, vertical angles, parallel lines cut by transversal, and definitions. I do see a pair of vertical angles that I could label. Nothing else I can label just because it looks congruent. And if I see the angle is included in between the 2 sides on both of these, that means that I have a side included angle side. I should be able to use side angle side. So given information, this goes here. Next, well, I guess both of those were given at the same time, so that was one of my sides. They also did given was AC and EC. Oh, I can't write out there. That sucks. I'll just put it right here. That's not good. Let's just say that goes right there as well. And that's another side. And then the third piece that we used was an angle, and that was these right here. So angle BCA and DCE. And that is the reason already put there for us is the vertical angle theorem. And that is the angle we're looking for. So that is the third piece. Great. Now we can say the triangles are congruent by side, angle, side. All right. Not too bad. Let's try another one. Oops. Didn't scroll there. All right. Oh my gosh. Disaster. All right. Here it says, given some information, proof. Great. Let's go ahead and get started. I guess I need to put it on the screen where you can see it. JK and LK are congruent. First piece of information. So JK, LK. JM, LM. So JM, LM. Well, this one's going to be easy. We got shared. We only have 2 pieces, but I do see shared sides. Feel very confident that's going to be what we got. So given information, you go ahead and just plug both of these in at the same time. I guess I got a little bit of room. Side right here, JK is congruent to LK. And JM is congruent to LM. That was another side. We are going to be using side, side, side on this one. So there's 2 pieces that were given. The third piece that we were using, we got from the pieces here. So Km is reflected across to Km. So that's how we know we don't switch the order of those. And that's the reflexive property of congruence. I would add that on there. And then now that we have our third piece, we have that side right there as well. We have all three sides. We can now say that KJM, triangle KJM, is congruent to triangle KLM by side, side, side. All right, let's find one more to do before I just give you guys some answers to these, and go to the other page. Let's see here. Bisects, that's a good one. Right angles, parallel, midpoint. Yeah, let's try one of these two. All right, let's try number 5. Looks like a pretty good one. All right, so for number 5, it says given ST is parallel to RU. So parallel, we don't put a congruency symbol on there, we just put that they're parallel. SR is congruent to not congruent, parallel to TU. So we put that they're parallel. Prove that these are congruent. So oddly enough, we actually don't have any information about congruence on these. So we're going to have to find all 3 pieces that we're going to use in terms of sides and angles. Let's start with our list of stuff. Vertical angles, no. Shared sides, yep, I do have some of those, so I guess I can go ahead and put that on there. Let's use green now, sounds good. So shared sides. The parallel is on there for a reason, and what am I usually able to label with parallel lines? Well, with parallel lines, we do have, cut by transversal, we have either corresponding angles that we could label as congruent. So like if I had 2 pair like this on parallel lines, I should be able to identify. Or I could say like alternate interior angles. So like this angle and this angle here would be congruent, and that's exactly what I have in this case. If I look at ST and RU as parallel, there's a transversal TR right here. And if I was to extend that out, that would be these 2 angles right here is what I'm looking at if I just focus on the parallel lines and the transversal. And the alternate interior angles are congruent. Same thing with SR and TU. If I have some parallel lines, I do have the same transversal going across there. I happen to have these alternate interior angles that I could label. So on the top side here, between the parallel line and the transversal, between the parallel line and the transversal on the other side, these would also be labeled as congruent. So now I do have 3 pieces of information. Both of these triangles, I do have 2 angles and 1 side. So I need to check and see what order I have, either angle, angle, side, or angle, side, angle for this one. So I just need to check, is the side in between the 2 angles or is it at the end? So if I look on the top triangle, SRT, I see the side is exactly in between. On the bottom triangle, same thing, in between 1 arc mark and 2 arc marks for the angles. So this is going to be angle, side, angle, what I'm using on this one. From here, now that I know, I'll go ahead and get started on the proof. So let's start with luckily it is fill in the blank here, so they got us started with the given information. I see they kind of broke it up into 2 pieces here. So ST and RU was the first piece of given information. That's not a congruency statement, so I can't put like an angle here and be like, oh, that's one of my, eventually, I can only put that for actual congruency statements here. So I guess I can put it down there at that bottom one, but that's one of mine. I don't even know the reason yet, but at least it's on there. In any case, that was given. But because of those parallel lines, as soon as I labeled these parallel, what was I able to label as congruent? Well, based on these parallel lines cut by this transversal, I was able to label angle STR here was congruent to, on the other parallel line and transversal, angle URT. And that is a congruency statement for angles. So that's my other angle that I have, and the reason is parallel lines cut by a transverse. You could say the reason is alternate interior angles. You could say alternate interior angle theorem. I don't know what they put on there, but I would have put alternate interior angle theorem on there. This was also given. And same thing, we were able to label these other two angles, SRT and UTR, the one that we put 2 arc marks on because of alternate interior angle theorem. And from there, I guess I didn't put the side on there. Oh, I don't know why there's another place on here. Oh, yeah, because that's not the side, and that's not a congruency statement. That makes more sense. I'm a goofball. I was looking at that as a sideways equal sign. We do need one more piece here, because that's not a congruency statement, so I can't. We do need the side. Obviously, I didn't even put a check by it yet. Where is the side? And the one in the middle. So you'll notice here that this is not a reflection. If I reflected this across, it would look something like this. S prime would be down here after the reflection. So R and T, side RT, doesn't actually map onto side RT. This is actually more of a rotation to map it on top of the other one. So let me get rid of the lines that I drew there. Oh no, I did it again. When you rotate this around, it actually, nope, cancel that. T is actually going to rotate onto R, and R is going to rotate onto T. And notice out of these two angles right here, you can tell by the angle markers. The angle with one arc mark on the top triangle up here corresponds to the angle with one arc mark on the bottom triangle. So the sides of these triangles, side RT is going from the angle with 2 arc marks to 1. On the bottom triangle, how do I get rid of oh, that works perfect. Is going from the top triangle is going from 2 arc marks to 1. The bottom triangle piece needs to go from 2 arc marks to 1. So RT is actually congruent to TR. Oops, I guess I need the pin back on there. And that's a shared side, so we would say reflexive property of congruence again. Abbreviating to save some space, but reflexive property of congruence. This is a congruency statement, so that's the side we are looking for. And now we can say they are congruent. So triangle SRT is congruent to triangle UTR by angle side angle. Once again, the order that you're able to get each one of these statements in here doesn't matter as long as you got this order correct and you've proven each one of those pieces. You can then use the correct statement here. I didn't want anybody to get confused. This order that you're able to prove them in doesn't matter. It just has to go, based on the information you're given. You can put whatever piece comes next. This order does matter, and that's obviously the only reason that we could put right here on this one. All right. I would suggest trying a couple of these. I'm just going to pause the video here, fill out all of the answers, and then I'll scroll through them so you can check your work. All right, so hopefully you've had a chance to work on some of these. Let's go ahead and check our answers. I did leave one blank just so I could talk about the very last one. You can pause here, check this one. And 4 and 5. Oh wait, we did 5. And then let's look at 6. So 4, if you didn't get a chance, check your answer here. 5 we already did, but if you want to pause and check, you can do that. And let's look at 6. So 6, label W and Y. First thing, angle W and Y are congruent. Oh, whoa, right angles. That was given. I'll go ahead and fill this out now just because it's given. And Vx and Zx are congruent. So Vx and Zx are congruent. X is the midpoint of Wy. So if X is the midpoint of Wy, this half is congruent to this one. So it looks like I have a angle side side, but it's a right angle. Angle side side doesn't work. So RHL. H is the same H, and then L is the same leg. So RHL is eventually going to be my reason down here that they're congruent. Okay, so then after I label that, I don't know. I would just put that they're congruent to. I would, on the example on number 3, I think it was, whichever one had the right triangle, it said they're a right triangle. I would just say that use it as a congruency. Angle W is congruent to angle Y. Definition of a right triangle, I'd just be like definition of right angle. And that way this works as a congruency statement, one of the pieces we're using. When it says that we have the midpoint here, that was given. But because of that, I was able to label that Wx is congruent to Yx. And that is my leg that I was looking for. And it doesn't have the other given on there. I guess we still need our hypotenuse. Where would that go? Vx. Oh, wait, it's right there. That's a congruency statement, so that's my hypotenuse. That makes sense. That part's the hypotenuse, but that part was the midpoint. Okay, so then we do have all of our pieces. We can now say they're congruent. So triangle VWX is congruent to triangle ZYX. And you may notice I just checked to make sure that I actually did use all these pieces here before, because if I didn't have one of the statements, like I mentioned, I didn't see this, I missed it earlier. I wouldn't be able to have this statement if I didn't have, or I wouldn't be able to have this reason if I didn't show that I have a congruent right angle, I have a pair of congruent hypotenuse, and I have a pair of congruent legs. All right. Hopefully you're getting better at this. I'm actually going to create a separate video for the other practice, because this one got kind of long here. So I'll make a shorter video for it. It'll be practice problems like this, but being completely blank, where you get to put in all of the statements and reasons, is the other practice page. All right, good luck. Bye-bye. Oh, I give up. I've been watching too many TikTok videos.